Hey everyone, welcome to another Make It Better. I don't know if you saw that, but Ian did a killer job bringing us in today. So if you see Ian or want to ping and chat at him, please do on the right-hand side because we are doing this live. We do have a little bit of housekeeping we got to do before we bring in our guest, which I'm super excited to talk with today. One of the things that we want to talk about is you may not have heard from us so far this year on a few things. And that's because the format of Make It Better is going to change a little bit this year. Instead of doing a monthly episode, we're going to go to once a quarter, and then we're going to have a little bit deeper conversation on different topics about obviously making it better. So with the housekeeping out of the way and the kudos to Ian for doing all the cool updates and intros, we're going to bring in our guest. And our guest is super cool and super awesome, and we've been chatting for the last hour. I wish we could have recorded it because it was the best discussion we've had in a long time. We have Taz from Arisoft. Taz, welcome aboard. Tell us who you are and what it is that you do and why you make the world such a magical place.
Thank you, Michael. Thank you, Ian, for the invite, and super excited to be here. Shout out to all the global audience participants of this live stream. My name is Imtiaz Lodhi. For people who don't know me, I go by Taz as well. I'm the founder and CEO of the Arisoft. We've been in business since 2005, helping manufacturing customers around the globe. Majority of our activities are within the North America, mainly US. And the journey began back in 2005 with helping manufacturing customers within the ERP, MES, IoT space. And that journey continued until we became partners with Dassault Systems. Previous acquisition, namely IQMS. We started our journey with them back in 2016 as the implementation partner for the product called IQMS, which later on became DELMIAWorks when Dassault System acquired it back in 2016. So the journey has been excellent so far, great experiences, and happy to be here. And back to Michael.
Yeah, and it's sort of interesting as we were talking in the back end, us both being in the manufacturing space. Yep. It's interesting how we all sort of have similar stories regardless of where it's at. And I think that's one of the cool things that we're going to talk about today is really whether it's ERP, whether it's MES, like at the end of the day, we're all trying to solve that solution to make parts faster, better, cheaper, right? And that goes from design in the front office all the way through shipping labels. And I know you have a story about that a little bit later when we get into some of this. But I do want to jump into the first question, and then we're going to expand out from there because I have all kinds of ideas rattling around in my head. But if I don't keep this on a trajectory, you and I will spend hours here just chatting. So my first question for you is, what are the most common breakdowns you see in traditional manufacturing environments where CAD and ERP and everything isn't connected? Like, what are those types of things that you see when you go into a shop and you're like, oh, Lord have mercy, this is sort of a disaster here. So how do you guys work through that? Because you guys are the experts at reining in the chaos.
Well, usually the customers do bring in is for the when you have these kind of like different silos of information, inventory mismatch, and the issues related around the revision controls. That's from the engineering side. So that's sort of like the areas that we initially, customers do bring us in.
Okay, so when you say bringing in, like, let's talk about some examples, because if let's say I'm using, I don't know, my favorite CAD system that happens to be, Red as an example. I won't give away any names, but it's that red brand. And I design a product and I say, great, I'm done. I'm going to ship it to the floor. And then I never think about it again. What happens to that design to actually go through a process to know whether we made it on time or not? Like, it's not as simple as, hey, I made this cool 3D model and here's my 2D prints. Like, where you come in with bringing, all of that stuff together, what are examples of the things that are needed after engineering's done with it?
Right. Well, it starts with the engineering BOM, okay? Conversion of the engineering BOM from the CAD into the ERP systems like manufacturing BOM setups. The customers do, start with taking that BOM information into the production floor, the matching with the demand side of the business. The customers' orders are coming in from orders planning side of the world. That's the area that we do focus on, in that part of the world. So the challenges that we are facing is related to the information silos, that area.
Okay,
But
so I'm gonna dig deeper here because yeah, because, and I say this because you and I had a conversation a little while ago,
Yep.
and I want to pull a little bit out here. So you mentioned EBOM and MBOM, right?
Yep.
And EBOM is generally what engineering creates that ends up on your cool drawing, however you made it, right? And this is what I need to have a completed product at the end, hopefully. Can you talk a little bit about an MBOM and why an MBOM, one, is different, and number two, it's important for what we do when we start talking about the manufacturing process?
Right. So, I mean, from the engineering BOM that is done typically in the CAD systems, the opportunities that we have with the integration is that ability for us to integrate those engineering BOM with the ERP system as a manufacturing BOM. We bring those engineering BOM into the manufacturing BOM and also maintaining at the same time, we have a revision levels that we do come in with the engineering side of the world. So this is the area that we focus on bringing in into the ERP world.
Okay. So if we look at an EBOM, it's, hey, I need this bar to be 1 inch by 3 inches by 6 inches, and it needs to be 1018 cold rolled and blah, 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 blah. But when we go to the manufacturing side to create the manufacturing BOM, we pretty much have to bucket it into, I am going to pull from this raw material that exists somewhere in the shop, and I'm going to cut it to that length. And then my finished part may be 6 inches long, but I need to cut this to be 10 inches long, and I need to track that difference, right? And I'm sort of jumping here in broad strokes, but when you start talking about what it is that you do with Arisoft, it's really taking that data and trying to keep it all in sync, right? Because I could see where engineering's like, hey, dude, I just designed this. Just go make it. I don't care how you make it. And the shop's like, well, there's a little bit more to it than that, because I got to know if I'm going to make 100 of these, how many bars I need and where are they located and stored. So can you talk a little bit about that piece? And then I'm going to have a follow-up question in a second, but talk a little bit about that portion of the process.
Sure. Got it. So essentially, not like, engineering side, once they are done, there's a series of things that happens on the production floor that needs to be sort of mimicked within your manufacturing BOM. So all the routing side of it, what processes that we need to do, which work center that it needs to get scheduled on, and what type of labor, whether it's a certified labor or not certified labor, needs to be get involved. So all these things do get mapped within your manufacturing BOM cycle process. Once that is done, then obviously the demand planning side of it takes over in terms of planning and scheduling.
Okay. So that gets us to my next question for you, which is, when a company decides to connect CAD and ERP and shop floor systems, whatever those happen to be, what does the architecture look like in practice? Like, how do you bring that together? Because to me, it looks like a bunch of spaghetti point solutions that all have to figure out how to talk. So when you guys go in and do those things, like, how do you figure out the architecture needed to make everything happy?
Right. I mean, that starts with the on-site visit and discovery, and then coming up with the solution or a right solution for their specific production floor needs. So each customer have their own unique sets of production floor activities that happens. I mean, some of them are into, let's say, injection molding versus assembly operation. Our part of the activity is to sort of map all these processes into a solution design that basically that's needed. That's kind of like where we match their production floor with the solution that we are delivering via ERP, MES, IoT systems.
Okay, so you look at the system that they have in place, and then you're
Yep.
putting in an integration layer that connects that. Am I understanding that correctly?
Correct. Yeah. Integration layer could be your, without going too much into the technical part of it. So essentially what we want to do is we want to look at the way that they are currently using the current processes of the system in terms of shop floor activity, and then look for the opportunities where we can develop a solution that integrates those different disparate system into a seamless workflow.
Okay, so let's assume here for a second, the company, you're talking to this company, you're going through the process, and we were talking ahead of time, and the owner comes out and he's like, I got a guy, and he knows how to do coding, and he can put these things together. What are the, like, in what you guys do, you're providing a end-to-end solution, top floor to shop floor and everything in between. What would you say to like the company where it's like, oh, I got a guy that can do it cheaper and do it XYZ, and it's just sort of like a fly-by-night, or in today's world of vibe coding, they just build this and they build this and they build this. How does like the patchwork system versus what you guys provide, where is the difference in that as far as success long term? Because I'm sure over the decades that you guys have been doing this, you've seen that I got a guy that does patchwork stuff, and you've seen the people going to the far end of the pool, and then there's the reality of where people are actually supposed to be. So when you look at those components, how do you have that discussion with people when it's like, I can do it cheaper, or I'm just going to go full tilt into some vision that I saw on, whatever TV show infomercial at 3 a.m.
Right. Well, about more than 80%, is handled through the out of the box available solution in the market, like ours and some of the other third party companies. The remaining 10, 15, 20% is the key where magic happens, where we shine versus, anybody can, let's say if somebody wants to do an MES solution, they can build their own. It just takes time, but there's a bunch of other risk involved, industry knowledge and experience. So the best is to stick with what the solutions that are available in the market, and then work on the fine tuning of the 80% that gives them the better edge than doing it on their own. Okay,
that makes sense.
Yeah,
absolutely. As you were talking about that, and part of the prompt is, way back in the early 2000s, when I was doing, laser and forming and things like that, and doing quoting and sort of building out that piece with SOLIDWORKS. The company I worked for at that time, we were small. We weren't in the late 90s, early 2000s ideal ERP MES bucket because of what we did and how it works. So we ended up having a guy build one that was on Access, and it did everything we need. And like to this day, it still does everything that they need for that size. But obviously, over 25 years, the sizes of ERP has sort of funneled it way down, where there's one for every type of size of business, I guess, from an SMB all the way up to the largest of the largest. When you start looking at like what you guys, where your sweet spot is, can you talk a little bit about where the sweet spot is for Arisoft to be able to help different levels of companies? And then more importantly, like in your solutions, at what point is it like, yeah, this is probably a little more than where we need to play, or you're a two-man shop, maybe this isn't for you? Like, how do you determine where the sweet spot is for whatever ERP you're going to buy?
Right. So I'll talk a little bit more about the need, the specific customer's need. Maybe they built these systems over the years, Excel-based. It does the job, but those solutions typically do not support the growth. As the company grow into, let's say, they're getting more customers and so on and so forth, their quality needs from their end customers are increasing. In those kind of pressing situations, their homegrown systems do not support that growth. Then on top of that, building something on their own using one or two or three or internal resources does not guarantee that the continuation and of the solution due to employee attritions or any other factors that may come into play. So the way that we do come in the situation where we are coming in with the lots of experience working on a similar integration projects or MES projects, where we tie in your production floor fully nicely integrated with the ERP systems. So your business system is fully synced as things are happening on the production floor. Essentially, it's kind of like a full 360-degree view of your organization, right from the demand generation to the planning to the execution, raw material acquisitions, and the production floor visibility. All this visibility within the one and only one system, meaning one version of truth. Yep.
Okay.
I'm not sure, Michael, if I did answer or over answer your question.
No, you did answer. And basically what I picked up was the key is if you're planning to grow long term and you don't want to be dependent upon, Bob the coder over in the corner leaving and you're high and dry, right? If the goal is a single source of truth, the best solution is to find something that functions more out of the box than everything is customizable one-off.
Correct. Correct. Yeah. That's sort of the remaining 10-15% where you actually get the most value out of the investment that you have done for a solution that you're going to live with for the next 10 years.
Okay. So when we start talking about this, we're looking at 10, 15, 20 years before we would ever entertain making a switch. This isn't like I like high-speed tooling right now. Tomorrow I'm going to run carbide. In a year I'm going to run full index cutters, and I can just sort of change as the wind and it all fits in my machine. We're looking for a solution for a decade to 15 to 20 years.
Correct.
Okay.
And this is a long-term investment. If we look at most of our customers that we started, let's say 10 years ago, these are the existing customers who are currently using the solutions that we developed, deployed. They are now looking at acquiring new companies that through acquisitions, those new demands do generate. And that brings more complexity to the system that they currently use versus the new company or acquired companies. There's a lot of M&A things that are happening, which is very hard these days. So that's also driving a lot of demand for these integrated solutions.
Okay. So I do want to remind everyone we are live. If you have questions for Taz, we'll take those as we go through. Before we get into MES and IoT, I do have a random question for you, Taz. So as you think back on your time and everything you've done up to what we've talked about to this point, is there a customer that stands out that you went in and helped and you're just like, they grew exponentially and they're just cool and it just puts a smile on your face that you got to be part of their transition?
Well, there's many examples, but I'll just pick one that recently they are expanding at a breakneck pace. A customer that started with their first implementation of the ERP out of the box. They did not go for the MES or connected to their machine or production floor. Everything was essentially a typical ERP system. They would generate your demand through the supply chain side of it, procurement. Everything was fully integrated system except the production floor. And I do remember the email, in fact, that I received after we turned on their real-time production monitoring. That was like, it's like one day. Next day, the CFO came in and he was super excited and talked about how excited he is to see what's going on the production floor. So that's just one example, and they are growing. They just acquired another 2 more plants in the States, and those some of those things that I do recall.
Okay. It's always good to have a happy customer, and I saw a smile there, Taz. So we're breaking.
That's a natural smile. Yes.
So we're going to jump now to another segment, which is MES and IoT. Before I ask the question for you, can you explain in your own words what MES and IoT is? Because we throw these acronyms around all the time, and I think a lot of times it's not relatable to a person that doesn't live it every day. So can you give your layman's term to someone that's not in manufacturing every day as to what MES and IoT means for what we do in the manufacturing space?
Sure. So the MES, or a manufacturing execution systems. Okay, so a lot of people interpret MES as that it needs to be a real time. Okay, MES can still be both signal and non-signal based. IoT, I'm going to cover that a little bit later on, but essentially what we're trying to do is we're trying to see if we can integrate our ERP or a business system. It doesn't need to be a fully ERP system, like your business operation or business operation supporting system to the production floor. And that production floor could be, helping improve your floor automation activities, or combining your production activities in terms of assembly operation, interlocking with the quality. Anything that's happening on the production floor with the integration with the ERP system is considered MES.
Okay.
And then IoT is more like going into the devices and then capturing data. That's more towards the, developing a solution, IoT solution. Anything can be an IoT. All these devices that you have currently not only on the production floor from that you built, but also coming in from the third-party manufacturers, like your electric panels, or how you're capturing your electric consumption, and all these other activities that generating data that can be captured and convert into a data analytics.
Okay, I'm with you. So IoT, Internet of Things, can be a big input device for wherever it comes from.
Whatever it comes from, and then you build a solution around it.
Okay, so we do have one question that came in, and I can't wait for you to answer this one. So the question is, did you send EBOM components directly to ERP and the MBOM as well? Was that routing created in the ERP without using PLM? And I'm going to let you go first,
yes.
And then I'll jump
short
into with
yeah, the short answer is yes. Depending on the complexity of your EBOM, sometimes the out-of-the-box solution do work, and sometimes we have to tweak the solution to build around their needs.
Yes, 100%. And here's the key for all my engineering friends that are watching. How you designed it is not how we build it most of the time. When you design it in a CAD system, you're designing it for revisions and updates and all these other things to make you as the engineer's life easy. That does not necessarily mean that is how we manufacture it. So there are times when you have an EBOM, and when we create the MBOM, it is a completely different structure. And a good case of that for the parametric CAD folks would be weldments, multi-bodied sheet metal, those types of things. You can design it easily in your CAD system. But how we break it down and how we nest it, how we sheet plan it, how we go to the laser, go through the multiple steps in the router, that requires an MBOM that is significantly deeper than how the CAD people designed it. So for the skipping PLM, that depends upon the size and scale of your company. But PLM, and again, we're using acronyms, whether I'm doing lifecycle management or data management, or even if I'm hopefully not putting it on a Windows Drive folder somewhere, to go successfully to an ERP, we have to do a case-by-case basis on how your process is defined to make the correct MBOM, because most of the time engineers design for their efficiency, not for manufacturability.
Absolutely. And I think I think you covered pretty much everything. I'll just add one to it, is that we capture within manufacturing BOM all the traveling of the components, right, from acquiring the raw material into putting this together, and whatever the process that it needs to follow, approved by the production team. And that's what the MBOM needs to follow, including all the cycle counts, how long it's going to take from, let's say if your manufacturing process do require curing and then part needs to be away after the paint cycle or any other cycle that needs to be. All these little details, like how long that curing process should last before the next step can be processed on that part or a subcomponent or a subassembly.
Yep, 100%.
We capture all these events. Yeah.
Yep. Yeah, I was thinking about as you were talking about the processes, I was thinking about back when I worked for Benson Machine Works in like 2001. We were doing these aluminum things for a company called Lab Interlink, and it was essentially conveyor systems that went through a hospital. So you would drop your stuff in, and then the conveyor system would move wherever. And they were all aluminum. They were super high precision. So we were laser cutting and forming within 2 thou of the original model that they had for tight tolerance. And then everything went out and got anodized and sealed because it was in a lab. So you couldn't let any material or any contamination into the material. And like, there was that whole process of, this is just a bucket that is really easy to laser cut and do. But by the time you added the certified material coming in, the laser cutting, the forming, the anodizing, the coming back, the checking, the fitting, like the M-bomb was 10 times bigger than what the E-bomb was, which was, this is just a flat part that gets cut 50 on a sheet.
Yep. Well, I mean, not to forget that, certain processes do require certain certified employees to work on, certified operators to work on. Those things needs to be part of the overall planning, not from the, just the resource and material planning, but do we even have the certified people to do that job that industry requires a certification on? So keeping track of all these things using the systems and make it part of the overall planning is something that these ERP and MES systems do help us achieve.
Yeah, you don't want the third shift Joe Blow operator working on something that has to be certified. Bad day.
Managing and certification from the workforce planning and HR perspective, managing, maintaining, sending notifications to the employers that their certification is about to expire. Those kind of details that this is what these ERP and MES systems do help employers, manufacturers.
Yep. Couldn't agree more. And that leads us to our questions. So it was a perfect time to get a question from our live stream because it leads right into my next question for you, Taz, which is, how do MES, IoT, and real-time data collection change decision-making on the shop floor compared to traditional methods like TPS reports and paper routers and all that good happy stuff? So how does that traceability transform how people do business?
Well, I mean, we're still in a transformation phase where the AI is being introduced. There's still kind of like, like earlier we were talking about before we went live, that juries is still out in terms of the AI execution on the production floor. But what we have beginning to see that the use of AI within the analytics space in terms of capturing the quality data for the events that are happening on the production floor vis-a-vis reporting of the production of good parts, bad part, quality defects, anything that's basically generated on the production floor, and its seamless integration into the smart BI, which is some of our, I think we're doing a couple of projects right now live that are that are related to the smart BI, where we're beginning to use what we call them natural language processing where Google style, where you're asking a question to within the AI engine and asking this question, and that basically brings back and this is on top of your existing BI dashboards and quality metrics and KPIs that are typically that people are used to, including the predictive modeling that were the case prior to the AI, if that makes sense.
Yeah, absolutely. From our side of the fence, right? We have Aura and we have Leo, and from the Aura side for the last year plus, we've been doing a bunch of stuff where we take standards, and like I did some tests. I took all my old shop data that we had for spreadsheets and how we operate, and I put it all in Aura and some wikis. And then from any time I'm designing, I can just ask it like, hey, what's the correct bend radius, or what's the feed rate for 1018 steel with my Fanuc robot, or what is the correct feed rate based upon this given thing. And based upon the language model, it comes back and gives me my specific needs based upon what my company was. So absolutely. I mean, that fits into that deal, right? Like, how do I securely capture my company information without giving it to anybody else, but then also not look at the world of data that sometimes, as we talked about previously, is not always the best from a global aggregate of information. But yeah, I mean, it's one of those things where I think the tribal knowledge component that used to exist in shops, right? They used to be hidden in documents and SOPs and things like that. You can now capture that data into a language model, be able to pull that, and it's specific to your company's needs. And I think, to me, that's sort of the next evolution of it, assuming you have good data coming in, right?
Right. Absolutely. Excellent. I think, I mean, you touch base on, I mean, some of the things that we have done in the past, and this is just based on our real life experiences with the customer, where these ERP and MES systems are helping them. This is just, I'm talking about helping or actually protecting your investment in machinery, in terms of managing the OEM suggested, recommended parameters, when to bring the machine down for the preventive maintenance. Those kind of data that needs to be managed, and then tie this OEM recommendation with the actual runs from those individual machines. So, because MES is actually capturing real-time data, so it knows exactly how many shots that's we have processed before the next preventive maintenance needs to come in, and we need to bring the machine down. So with the intelligence, with the MES systems that we have these days today, system, as part of the planning schedule, system automatically spits out the preventive maintenance work order, and it plugs it into as part of the schedule. Let the planner decide whether they want to actually bring the machine down or move or ignore the preventive maintenance work order, which is also commonly known as MRO orders as well. So those improvements and those efficiencies are available. Just these, and by the way, there's no integration involved. This is out of the box solutions.
Which is, I mean, that's a pretty big thing, right? When you think about it, in the past, like, you'd have to have the maintenance guy be aware of what's going on and then have to go talk to someone to make that suggestion. Now, as I'm doing scheduling, hey, I'm going to run for the next 120 hours, but in the middle of that 120, we're at our suggested interval for taking it down for 4 hours and doing all our PM stuff.
Correct.
Yeah,
and then exactly. And then I think, while it just dawned on me about not only that, okay, how do we combine different type of job orders, work orders that are on similar family and that do not require kind of like changeover or the setup time that is required. For example, if I'm running a same color, how many work orders that I have that I can process use while I'm still running white, for example. So those kind of efficiencies are already considered as part of the MRP and production schedules that we run. These systems that are intelligent enough to be able to actually combine those orders in a way that helps reduce the setup hour time or changeover time.
Yeah, suggestions for batch processing is huge, right? Because in the past, you'd have one person that's sort of the guru looking ahead at the future to determine, okay, if our setup changeover takes 45 minutes, can we run 3 more jobs before we do that to increase that throughput? Yeah, those are the types of things with AI and those components that really make a difference in how the future is going to look. Because again, everything we're talking about is that tribal knowledge component, right? Generally in the past, you'd have a person that's the master of tribal knowledge. Now we have a solution that can look at those and provide suggestions or outputs of like, hey, it might be better if you do X, Y, Z, A, B, C. As we get into tribal knowledge, I have a next question for you, Taz. And we are live. If there's more questions that come up from this, feel free to jump in. The last one was pretty amazing, and that led us down the path of where we're getting here. So the next one is, if a manufacturer is still running on spreadsheets or disconnected systems, that tribal knowledge component, what are the first 2 to 3 steps to realistically begin that transition into, I don't know, the 23rd, 4th, 5th, 30th century of how we're going to handle data? So what would that look like? Where do you see people in that progression to get where they want to get, even though they might be starting with very heavy tribal knowledge of Excel spreadsheets and things of that nature?
Well, I mean, what we have seen, I mean, every customer has at least like 5 to 10 projects that they like to do, but don't have time or resources available, and, due to competing priorities. I would start with something that, has the biggest business impact, both in terms of time availability and the dollar impact of the issue that they have in hand, or a challenge that they have in hand. So we would start with that, and then we go from there. But they need to come up with like, okay, I have these 5 problems. Which one Arisoft you can help us with?
So I have a random question, Taz.
Sure.
So when you guys go out and do your consultation, do you sort of do it like Office Space with the Bobs, where you sit down at a desk and you're like, so what is it that you actually do here? And you ask them all those things? Or is this more of, they give you a presentation of, here's the 5 things that we want to do, and then we go forward? I like to think it would be more fun to have the Bobs asking everyone what they do here, but I'm sure that's probably not efficient when you do it. So when you go to do that consultation, how do you handle bringing those components together and getting honest answers to the questions you're going to ask? Because I could see where it'd be easy for someone to be very guarded because they think their job might be on the line, similar to what the Bobs would do. So if you could go through and enlighten a little bit on how you go through that Q&A discussion back and forth to make sure that you're getting good information to suggest the right decision.
Well, I'll give you one live real example here. I mean, one of our clients acquired a slitting machine, for example. They did, now that machine is sitting on the production floor. They wanted to introduce the robotic arm that they also acquired from another company. So these are multiple systems provided by multiple suppliers, and these are individually programmed and executed, got the results back. But this is all happening in silos. So this is just one example of like, okay, I have ERP system that is generating my work orders. I have this third-party hardware that I use, where I use the robotic arms and install my roles on it, and then it does the slitting job. Once the job is done, I do the HMI programming, tell the machine what I need, and how far it needs to go and cut, managing those affairs. Then we need to put this thing on the third-party conveyor belt that someone came in and installed it for them, that has an integrated weighing machine. So all these systems are on the production floor, but each of them are maintained separately. That's sort of like, this is just one example, and there are many, many other examples that are out there. So in this case, they have engaged us that, hey, what can we do to basically help automate all these processes? And one of our consultants would go out and actually map the production floor, walk the floor, discuss all these challenges that they are having, and then come back with a design or a proposal for them to review and accept.
Okay. So oftentimes when you guys are brought out, it's like, hey, I have all this data, I don't know how to bring it together. Is that sort of how the process works?
Yeah, the impact is that, can we do to eliminate the number of clicks? What can we do to sort of, so the data flows seamlessly into the, we'll call them mother software, if you want to call it, which is ERP. Everything ends up in ERP, and everything that ends up in ERP, no matter where it comes from, it goes into the finance. So the firm, the financials are tightly integrated with the production floor.
Okay.
So that's sort of the, what we call it, problem statement in this case.
Okay. So how do I know that I'm actually making the money I'm supposed to be making at the end of the day?
That's the biggest one. Yep, that's the biggest one.
Okay. So another question for you, and I think this ties into what we were just talking about here a little bit, is what measurable business improvements do companies typically see after implementing ERP and MES? Like, you put the whole enchilada together, what do people generally see as the outcome once they go through the transition, get it up and going, and it starts running on its own?
I can answer it in one sentence. One version of truth. So we're not maintaining different numbers. Everybody's working on the same numbers, provided you have a quality data management. Once you do the good data management, the numbers, and everybody's going to be looking at their own areas, but it's the same system, same number through and through organization.
Okay.
That's the biggest benefit.
So when you're talking about, you mentioned quality there. So if we're talking like a QMS or a quality management system, we're tying in all that data into the routers and travelers as well, correct?
Correct. Not only that, we're also, depending on the individual customers requirement, I'm talking about, we're all serving end customers here. If they have any particular requirement where you cannot complete the process without quality inspection by the operator, supervisor, and so on and so forth, that's where the interconnected or interlocked quality comes into play. That these systems do not let you do the production reporting or a process completion without quality doing the job.
Okay. So I'm thinking about this, and we've talked about a lot of very pointed sections of the process, right? Mm-hmm. And I think one thing that we probably need to quantify a little bit is the amount of data that we're talking about. Because, if you're talking like a manufacturing facility in 1992, the amount of data that was generated is almost zero compared to the amount of data that we're tracking today. So when you start talking volumes of information, can you sort of quantify that for people? Because I think, if I'm an engineer, I'm only concerned with parts, assemblies, and drawings for the most part. I know I'm simplifying here, but if I'm a machinist, I'm talking about the CAM, the CAD, the post, maybe a setup sheet. If I'm talking about a robot programmer, it's the pendant and the code. But like when we start talking about the whole infrastructure of what it takes to put a project together, can you sort of give like a perspective on the amount of data that actually we're tracking to make the right decisions with?
Sure. There's a lot of questions in it, but I'll try to keep it within the MES context. MES, nowadays we are capturing real-time data directly from the machines. So both the production reporting data, but also we have the ability to capture process data, the temperature, gauge pressures, and so on and so forth. That is, all these machines are generating tons of data. So we have the ability to not only capture that data in a real time, make the inventory available as produced, as the finished goods are produced on the production floor, making them available for onward shipments and fulfillment of the orders. But a lot of data, I'll give you one example of one of our largest customers in the States. They are generating probably more than 200 plus machines data, process monitoring data, tons of different tags that are generating all the quality data that they need. And that data, not only that they're just generating and storing it somewhere, but they're actually developing analytics on top of that. That is not only used just to help them with their operations, but also, it's kind of like it becomes like full auditable tracking of, what machine was running at what temperature at what time. This is just very plain, simple example, but there's more to it. The people who are working with this data, know how to, especially the management team or on in the production, they have they know how to best use of this data.
Yeah, if I don't know if anybody was at 3D Experience World for the last several years and you came by the shop floor, I think oftentimes we sort of downplay it a little bit, but like as an example, the DN machines that we had from Ellison Technologies, like we're pulling 20 different pieces of information as that part's being cut and machining and running, horsepower, electricity, uptime, downtime, the spindle speed, the XY travel, acceleration, deceleration, and that's just from one single machine. So you start talking about multiple components and PLCs and all that, and you have 15 to 20 channels per piece of equipment, and it really comes into what you see today in the news, right? Like, oh, X car maker has a recall and it's so many hundreds of thousands of vehicles, and oftentimes you're like, well, how do you know which vehicles were affected? Well, that comes from all that MES IoT data, because they know if that part failed, they know which vehicles that part was used on, because all of that manufacturing process is data and tracked down to the time that component was produced. And I think it's so seamless that a lot of people don't realize how much data is actually being tracked these days.
Absolutely. And I think one of the things that I did not cover in my MES data collection, especially the process monitoring, the ability to generate automated alerts if this machine is overheating or a certain pressure is not meeting the threshold. We can develop unlimited alerts. Our customers, like one of our clients, actually, this is just not only these alerts are actually data driven. So this is real, this is happening in order. And then once you schedule these alerts, they're just kind of like sitting little AI agents that are constantly monitoring the qualifying criteria to be woke up, and then start alerting, sending public notification, emails, and also the text messages to the supervisors or whoever needs to be known.
Which is a big difference from way back in the day when it was like, well, we were on third shift, we didn't know what to do, so we just kept running them, and they're all scrap. But I met my production rate for the evening, even though I scrapped X amount of parts. Right now, it's like, no, stop, don't do any more. Let's protect what we're doing.
Yep.
So,
and I think when you have the red light blinking on the machine, that allows them to actually go find the supervisor if it's not on the production floor.
Yeah, and that's the cool part. One of my good friends, Scott Volk, here in Nebraska, he had a bunch of that stuff set up, and I know he's doing a bunch of stuff with AI now up at Wyand up in Norfolk. But that leads me to the next and last question for you, which is looking ahead. What does the next evolution of a smart factory and AI look like? Like, where do you see what you guys do and provide with the addition of AI to help companies make better decisions? And I don't know, let's say the next 5 years, because between now and the next 5, it's going to completely change again.
Well, it's surprising everybody every 6 months to a year time these days. So it's hard to catch up with the evolving technologies. And but we are beginning to see a lot of our customers actually starting AI-driven automation projects, not just the production floor, but through the other operations like AP automation. So removing a lot of like touching points where you need to actually take that vendor invoices and manually enter into the system. That's just the one example. On the production floor, we are looking at the data that we are generating, how to best harvest that data and make them into actionable items. So that's where I think I tried to address that in the beginning or somewhere during the call. The NLP use, or natural language processing use, as we're developing lot of amount of the data that we are feeding into the data sets for the AI, we are able to generate some quality analytics using that data. So that's the areas that we are. Now on the production floor, I don't know where we're going to be in the next 5 years, but what I can tell you that some of the recent experience is that there's a huge emphasis on the automation shop floor, not only the shop floor automation, but also in the warehousing world. Within the warehousing, we have seen automated warehousing, use of AMRs, taking essentially finished good pallets dropping it into the automated warehousing bay, and then off it goes. And those kind of efficiencies, automated erection of the cardboard boxes, the boxes, the labels are like, label is one big thing, as you know, that labels are extremely important for our clients. Label makes a big difference. So not only the printing and labor, application of the labor through the automated processes, or the automated appliers inside and outside the coils. Lots of these projects, I can continue to go on for the next 5 minutes in terms of number of projects and different type of business cases that we solved for our manufacturing customers. This is just more like a snapshot of them. Automation.
Yeah, and I think the addition of vibe coding is going to change it too, because now you're lowering the barrier for people that may know what they want but aren't specifically coders, now have the ability to build those apps to solve that problem. And then once that framework's built, they can plug it to anything else, right? So I think that we probably are just scratching the surface of what's going to happen. But I think, to what you and I were talking about before the call, is it all comes down to the quality of data, right? Like, you can create an enormous amount of garbage these days, and that doesn't really help your business. So the use of good quality data for your specific factory is the key to success or failure.
Absolutely.
Yeah. So with that, Taz, it's been great, my friend. We had a couple conversations off record, as well as, what we've done today. What you guys do at Arisoft and what you do to help customers is pretty amazing. And I can't thank you enough for taking an hour out of your busy schedule to be able to impart some cool knowledge to everyone here today. So thank you so much for joining. I really appreciate it. Do you have any last words? Where do they go to find you? What's your website? Like, we gotta promote you a little bit here too.
All right. Thank you, Michael. Thank you, the audience. Thanks, Ian, for making this arrangement, inviting Arisoft, myself, to participate in this fantastic live stream. I wish we had more time in terms of to talk about some of the example, but if anybody would like to reach me, I am available on LinkedIn, Imtiaz Lodhi, or company name is Arisoft Global. I'm just going to bring this down to a little bit so you can see. No, it's the other side. ARISOFT, arisoftglobal.com. And you can just reach out to info@arisoftglobal.com or sales. But thank you for the opportunity. Thank you for this great conversation. Exciting times ahead. We are all busy. The manufacturing is coming back. We're seeing a lot of M&A activity. So everybody seems to be busy, which is a fantastic.
Yes, very busy. That's always a plus. And you and I work in the world of, there's not enough people to do manufacturing. So if you're thinking about, what is my next career? Let's say you're not decided on along a path like you and I have been in for decades now. Manufacturing is a cool upcoming place that is amazingly high tech. You want to get into IoT, MES, connected systems, robotics, virtual factory. A lot of what we do, you mentioned AGVs and AMRs. We're doing lots of throughput studies with customers now of how does the AGV AMR work in conjunction with a forklift or a human or an overhead crane. There is all kinds of high-tech, amazing things you can do in manufacturing. And the whole goal is to make it better. So with that, we'll see you next quarter. Thanks again, everyone, for joining. And if you have any questions, feel free to reach out to Taz or anyone at solidworks.com. Thank you guys so much, and we'll see you in Q3.
Thank you.